Okay. Sorry, guys. Sorry for that. So this is a quick agenda for this session. So I'm going to talk about introduction to AWS, go through some of the benefits of using AWS. What are the typical core AWS services that we have? Typical use cases that customers we see customers leveraging AWS for. And at the same time, we also see what are the various use cases that customers typically get started onto AWS. And during this course, please feel free to ask as many questions as you want. Towards the last 15 minutes, we have blocked some time for the Q&A session where me and my colleagues will actually be answering your questions. So please feel free to ask as many questions and have a good takeaway from this session. All right, so let's go and jump into the introduction to AWS, a quick history of where Amazon Web Services comes from. So AWS is one of the three lines of businesses of Amazon.com. Perhaps you already know that we have the consumer business in the form of Amazon.com, Amazon.in, etc. in India and so on. So these are the consumer portals wherein anybody can select from the millions of product varieties that we have, order those, and get them delivered to their homes. The second line of business, which is the seller's business, wherein any third-party business can actually start registering their products onto AWS and fuel their business through the Amazon.com portal. Now, this business is what was fundamentally responsible for this entire web services concept that came in and how this actually got started adopted, wherein we started exposing some of the API calls for catalog search and all that as an API call to the third-party developers. And we saw a huge positive feedback from the developers coming in while searching those catalog items and being able to list their products easily onto the Amazon.com portfolio. So that is where that gave us an idea of creating an API-driven environment, not only for cataloging and all that, but also for the entire IT infrastructure. And that is where it came in that AWS was thought of, and IT infrastructure business is something that we launched back in 2006. So it was not known as cloud computing, but over a period, we have been, so this has been called by cloud computing by the industry. We have this DNA gotten from the Amazon.com, wherein we are very comfortable in operating in high volume, low margin businesses. And more importantly, we take customer obsession and customer feedback very, very seriously. Which means that any feedback that comes in from the customers, we include that as part of our roadmap or the development of our services. Over a period, over the last 6 years, we have been launching a lot of services based on this feedback. We believe in rolling out services which are relevant for most of the developers, and then get the feedback from the developers and end users, and keep on iterating on those services rapidly, so that we keep on adding to those services as we go forward. Right, so these are the set of services that we have launched over a period, and we keep iterating over those. We also have a global footprint, and we see customers adopting our global infrastructure at that scale. Customers normally start within their own geographies, but then they prefer to go global once the businesses grow, once they have better exposure, etc. And we've got over 1 million active customers today across 190 countries. We've got 900 plus government agencies, educational institutes across the world. We've got 11 regions across the world, and regions are a collection of data centers, which in our terminology we call them as availability zones. And we also got 53 edge locations, which serve as the content delivery POPs or the POPs for the DNS services. What's important here to understand is that we got so many regions across the world, and we are adding more and more depending upon the customer adoption and seeing the customer growth. We keep on adding to that capacity and add more regions. Some customers pick up one region over the other due to cost implications, because given the way we keep on optimizing our cost structures, the cost in some of the regions would be lower as compared to the other regions. So the cost could be one reason. The other reason that customers typically pick up for picking up the regions is the vicinity to their audience. Like if your audience of your application or your website are near to that geography, then you would obviously pick up that particular region. This is a quick snapshot of the enterprise customers across the world that we have. And if you would have noted that these customers actually cut across the multiple industry verticals, such as product companies in the form of Ericsson and Nokia, oil and natural gas companies like Shell, banking and financial customers like NASDAQ, Bank Inter, and so on, media and entertainment customers, pharma and research, and so on. So there's a whole different set of customers that we have on this platform who have been leveraging the AWS environment for a multiple use cases, which includes test and dev, running backup, or running their entire DR websites onto us, and so on. We've got over 600 government agencies and 2,400 educational institutes worldwide using AWS, and these range from government agencies like NASA JPL to the City of Melbourne, and quite a few universities in the US are actually leveraging the entire platform. Again, a lot of born in the cloud or the startup companies like Instagram, Pinterest, Airbnb, who have been disrupting the entire space in which they launch their products, and for them also AWS has been #1 choice because of the variety of reasons which we'll see in subsequent slides. And they really push the limits in terms of scale, elasticity, and the flexibility that they get in the platform. They put in extremely innovative, wonderful workloads onto us, companies like Netflix, etc. Over a period, what has happened is that customers have actually demanded from AWS even wider set of services and product suites that they should be able to leverage from AWS. And that is where I think AWS has a very important role of getting more and more SIs and consultants onto the platform. And today we've got more than 5,000 system integrators and more than 3,000 independent software vendors who have listed their services and products onto our portals. We got global partners such as Accenture, Infosys, Capgemini, etc., who are giving their SI services to the AWS customers and enabling them to adopt AWS. At the same time, we have also got other vendors such as Microsoft, Trend Micro, SAP, Oracle, etc., who have certified to run their products onto AWS, and depending upon your agreements and the agreements that these customers and partners would have, you could actually bring in the original license or something called license mobility. You can use the license as such into AWS, or in certain situations, the license is also available in AWS on a pay-as-you-go model. Even beyond that, we also have something called AWS Marketplace, wherein some of these companies that have been listed, they have actually published their products onto the AWS Marketplace, so that the customers looking for any of these services can just go to the Marketplace and subscribe to those services seamlessly from there. And again, the licensing model varies between the bring your own license or the license included versions as well, depending upon the tie-ups that these partners do with us. But this makes it easy for our customers to search and spin up a product or a service quickly. Let's talk about some of the benefits of using Amazon Web Services. Security remains the #1 priority for AWS. Some of our most conservative customers have actually found that security in AWS is better than or almost equal to the better security to the security profile that they are able to create in their own environments. And as you can see, we've got multiple certifications and across the board, which include some of the industry standards like ISO compliances, PCI compliances, MPA, and so on. And of late, we have also been able to secure the security controls which specific to the cloud services like ISO 27017, ISO 27018. What's important here to understand is that the overall set of AWS services and the security portfolio in there allows you to have a complete visibility, control, and auditability of the entire platform. When we say visibility, we give services such as CloudTrail, etc., which allows you to have a complete visibility of what all API calls were fired in the AWS platform, when those were fired, and so on. So it basically gives you an entire audit trail. And with control, we basically have those fine-grained controls down to every resource in AWS, which allows you to create a very strong authentication and authorization mechanism as to which user should be allowed to do what. So some of these things are actually built into the platform as such, and a lot of customers actually find it much more easier, and they get a much better experience of the overall security in AWS as against what they would try to do on their own. This is another differentiation that AWS would have, and that's with the experience with operational reliability. This, along with security, remain the top priorities for AWS. As I said earlier, the entire thing has gained heavily from the experience that we got from Amazon.com, and the scale and the level at which this entire platform was maintained and offered, as a lot of services were offered in a services model to the end developers. And that gave us a huge benefit to us in terms of the experience that we got from running that huge infrastructure. What that means is that our engineers are relentless in their pursuit to eliminate any potential causes of failures, and we also build the availability zones in such a manner that they're isolated from each other from fault line, floodplains perspective, fed from different ISPs and power grids and so on. And on top of that, we also have the team of solution architects who can help you adopt the best practices and the architecture patterns that are normally recommended. But this has so that, as we said, there is no compression algorithm to experience. So we have gained this huge experience by having run such platforms over a decade. So apart from security and operational efficiency, the cost also remains an important point for our customers. We understand that no two workloads would be similar in any customer environment or even across customers. And that is where we believe in multiple purchase models or the different billing methodologies that we have, which include on-demand, reserved, and spot, wherein depending upon the variability in the workload that comes onto the AWS, you can actually pick and choose the different billing methodologies. Cloud computing inherently is a high volume, low margin business, and once we see the demand increase on our platform, as the consumptions increase, we are able to get better negotiated price from our vendors. And once we get those cost structures improved and we see the cost benefits coming in, we believe in passing those benefits back to our customers in the form of price drops. And what that allows us to do is keep on reducing the prices, and customers choose the various billing methodologies that we saw earlier. So far, we have had 50 price reductions over last 7-8 years in the customer, and we have been passing all those benefits back to the customers. Another important point that customers tell us, and we also believe in, has been the increased agility. While the initial discussions do start around the cost as to how costs on AWS will be better than the overall total cost of ownership on a physical environment, but over a period, customers realize that even though cost is important, but whole aspect of being able to spin up infrastructure quickly at that reliability and that scale becomes even more important parameter for them to decide. So while in old world infrastructure, it would take many weeks to really get the infrastructure in and get deployed. Whereas in AWS, if you want to start more and more experimentation, you can spin up the environments with a click of a button, no matter how small or big those environments have to be. What that allows companies to do is inculcate a culture of innovation within those within their own departments, so that the people can experiment often, fail quickly, fail fast, and fail forward, and be more innovative and try to do as much experimentation as possible without worrying about the sunk investment or the unused hardware that might just be left back. Whereas in on-premises, it is practically not possible to have so many experiments parallelly without worrying about the sunk investments, etc. So these are some of the benefits that we see in the AWS services that we have. Now let's jump into some of the AWS services that we have across the board. As I said earlier, there is a global infrastructure of 11 regions, 28 availability zones, and 54 edge locations across the world. Availability zones are nothing but a collection of data centers which form a region. These availability zones are isolated from each other, as I said earlier. So these are some of the core services built on top of that, and as you can see, we categorize them into network, compute, storage, and so on. As customers get more experienced on the AWS platform and start creating complex set of applications, that is when they start adopting higher level services, as are shown here. It's a very broad set of services, and this again is a big differentiator for AWS when customers really want to evaluate the overall breadth of the platforms. We also have enterprise application sets like Workspace, Worktalks for remote virtual desktop infrastructure, as well as document sharing. Right, so let us quickly look at the compute services. So these three services form the core or the pillar of most of the compute services that we have. Amazon EC2 or Elastic Compute Cloud are the virtual servers in the cloud, which allows you to pick up the size of the server. Those can range from a single core to a multiple core machine, and from a 1 GB RAM to almost 240 gigs of RAM, and so on. So it allows you the flexibility of picking up the size of the machine as well as the operating system, which could be a Windows or the multiple flavors of Linux that we have. Another important service in the compute vertical is the auto scaling, and this allows you to really scale the compute capacity depending upon the load that comes onto the platform. What it allows you to do is also not provision for the peak capacity as we used to do it in the physical infrastructure. You don't need to plan capacity beyond a point. The compute capacity actually follows the load that comes onto the platform and really allows you to take benefit without you having to worry about over provisioning, and more importantly, it gives you an excellent customer experience to the end user. Another service is the Elastic Load Balancing. As the name suggests, it's a load balancer service, and you can spread the load across the multiple EC2 instances below it, and it will equally distribute the load across these servers. And moving on to the next, so the networking services, we've got Amazon VPC, Direct Connect, and Route 53 in the networking portfolio. VPC basically allows, or the virtual private cloud basically allows you to create a private isolated section of the AWS cloud. It typically allows you to replicate the network environment that you would typically create in a physical network, having subnets and so on. So the same set of subnets can actually be created here, along with your own definition of public, private, NATed, and so on. So you can create the same network that you would typically create in a physical environment. And to connect to it, we've got multiple options, one being the VPN tunnels over IPsec, and the other option that's shown here is the direct connect, which is a private connectivity from your data center or from your offices straight into AWS, which can bypass the entire internet and give you predictable low latency straight away into the AWS data centers. Very useful service, and customers actually leverage it to have a secure, safe connectivity into AWS with the minimal of latency, and at the same time extend their entire data center into AWS cloud seamlessly. The other service is the Route 53, which is a domain name service wherein you can start registering your domain and create the records, etc. In Route 53. It also has some of the features related to weighted round robin, latency-based routing, health checks, and so on for you to create highly available systems across the geographies. Moving on to the storage services. So over a period, our storage services have really expanded to a very wide portfolio. And we will be doing dedicated webinars around storage as well as some of the other best practices. So please make sure you, if you're interested, you attend those. But at a high level, we've got Amazon EBS, which is Elastic Block Storage. It's, as the name suggests, it is a block store which you attach to an EC2, format it with your own file system, and then use it. Can scale from to a very high number of IOPS, up to 20,000 IOPS per EBS volume. And again, EBS itself has three different variations depending upon the use case and the price point that you're willing to pay. You can pick and choose the variety of storage volumes in there. S3 is amongst the first few services that we launched. It's called Simple Storage Service. It's an internet scale storage via API. You can use it to store any of the static content like the images, video files, HTML, JavaScript, CSS, and so on. The typical use case being write once and read multiple times kind of scenario, wherein you upload a file and that file will perhaps never be changed again. So you can upload all of that content into S3. S3 by design gives you 11 nines of durability, which from a statistic point of view means that your chances of losing an object in S3 is 1 in 100,000 years. So that's the kind of a number there. Provides you, again, S3 also has a few variations in them in S3 service, which ranges from 11 nines to 4 nines of durability, and also there's something for infrequent access as well. So depending upon the cost and the criticality, you can actually pick the different varieties of or the different types of S3 service there. Glacier, again, the name, as the name would suggest, it's for archival or it's a cold backup. You basically start archiving the content into Glacier if you do not want that content to be available online. Once the content has been uploaded to Glacier, it also has the same levels of durability of 11 nines. However, since it's offline, so you need to fire an API or go to the console to retrieve that object, and that object will be made ready in a matter of few hours. But point is that now you don't need to augment your on-premises SAN or the tape library-based environments to really secure the data, because the levels of durability that S3 or Glacier will be able to give may not be easily achievable in on-premises infrastructure. Moving next to the storage gateway. Storage gateway exposes an iSCSI interface which can be mounted to the multiple servers as the mount point onto the local systems or the on-premises environments. And again, instead of dumping the backup data or uploading or archiving some data into local SAN environments, you can start uploading the content directly into the S3, which is an infinite storage. And again, it also supports something called VTL, or the virtual tape library, which allows you to, instead of using the local tape library, you can actually start importing everything into Glacier. So it acts as a gateway, and you can start leveraging this gateway right away to upload the content into cloud without worrying about scaling your on-premises storage infrastructure. Moving on to the database services, again, quite a few services in this portfolio, and we've had quite a few more as well, not mentioned here, but I'll talk about those. Amazon RDS is the relational database service. It gives you multiple database engines such as Oracle, SQL Server, MySQL, Postgres, as well as MariaDB. All of these database engines can actually be spun up instantly from the RDS console itself. It's a kind of a managed service, which means that everything below the schema is managed by AWS, which includes the backup, patch management, fail node replacement, and stuff like that. And schema above is something that customers usually take care of. So that's Amazon RDS, or Relational Database Service. We also have our own engine called Aurora, which is a drop-in replacement for MySQL and is designed to give you a high scalability as well as the low replication lag times between the master and slaves and read replicas, etc. It's our own DB version, but it's totally compatible to MySQL, which means that if you have a running MySQL database in your system, you can dump the data as such into Aurora, do your evaluation, and check out the complex queries and the performance that you get out of that. Next is the DynamoDB, which is a managed NoSQL database service. It again provides you a very low latency, highly consistent database, consistent low latency database. What is important to understand here is that can scale automatically for the amount of storage that it the capacity. And other big advantage versus other NoSQL is IOPS consumption. So in other databases, to really add more IOPS, you need to add nodes or player. Whereas here, the entire IOPS is a tuning feature where you can start with something as small as and keep on growing the IOPS depending upon the requirement. Then we also have a Amazon Elastic Caching service. We support Redis and Memcache as the engines. Then we also have quite a few big data services. Amazon EMR being Elastic MapReduce, as we call. It's an hosted spin up a big or a small cluster depending upon your requirement. You can spin up a 10-node cluster to 100 node cluster when the load when there is when you want to finish the jobs faster, and then shrink this back to 10. So it gives you that inherent scalability of to go down to the node level and configure the cluster, etc. Because that itself is a pain. So avoid that by just spinning up the cluster to the size that you want, and then it also gives Impala, Hive, Spark, Pig, etc. built in as part of the cluster, so you don't need to do any. You can just spin up the cluster and start firing jobs to it. Data pipeline is for AWS services or even the on-prem data sources. It allows to messaging as well, and then move the data from one point to another. Redshift is a petabyte scale data warehousing architecture, massively parallel processing. Again, you start with one node and then keep on adding more nodes, and the overall will also increase according to that. Again, Redshift is Postgres client to Redshift using any of the Postgres clients. Another important aspect is the vendors have actually certified their products to run with Redshift. There's like Jaspersoft, Tableau, MicroStrategy, and so on. They have actually certified their products to run with Redshift. So if you have those, into Redshift and leveraging the current investment. Moving on to the next set of services, Amazon CloudFront is a content delivery network. We've got globally distributed POPs, which can be used to cache and deliver the static content like the HTMLs, the JPEGs, and so on. In addition to that, it also allows you to deliver the video content such as on-demand video or the live video streams that can be delivered from our global POPs. We also have a search service called Cloud Search. Today we have Solar as well as Elasticsearch, and depending upon those services, there will be a slight variation in the APIs that have been exposed, but we are happy to talk to you if you have a use case around this. Please feel free to reach out to us. Elastic Transcoder, again, is one of the edge services which allows you to do a video transcoding in the cloud. A lot of customers have asked us that they spend a lot of time and effort to really manage the transcoding fleet of servers, and Elastic Transcoder basically avoids that entire overhead of having to manage that kind of infrastructure. So you just upload the source video, and Elastic Transcoder will actually pick that source video and transcode into multiple different formats. So it basically does the entire undifferentiated heavy lifting of transcoding the videos and giving you the targeted outputs. A lot of presets are already configured in the Elastic Transcoder servers, but you can always configure more custom presets as well. Deployment and administration, so this basically covers the monitoring and the other management related service around authentication, etc. CloudWatch, for example, allows you to monitor all the AWS services. Identity and access management is basically allows you to create a role-based access control, also does the federation services, either with the social media or with the Active Directory, ADFS, etc. CloudFormation, OpsWorks, and Beanstalk basically give you a varying level of fine-grained control on the entire customization piece as to how you would like to launch your infrastructure and the level of customization that you would like to do on the applications that you deploy in those systems. So these are the three deployment services giving you a varying level of control on the deployments that you do in a scale-out cloud model. So let's move on to some of the typical use cases in AWS Cloud and see what customers have been leveraging that. Web, mobile, and social apps. So this is one of the core or some of the basic applications that a lot of customers leverage. So they basically create a tier of databases, a master and a slave across two availability zones, and then set up a set of application servers below a load balancer, and then a web tier below another load balancer front-ended by the CloudFront and S3, etc. service. So what this allows customers to create is a highly available and highly scalable environment which can scale independently of each other and without having any single points of failure. Also, it's important to note that this entire environment can actually be securely created in a VPC, the virtual private cloud, so that you only expose what is required to be exposed to the end customer. Next is the big data. So this again is a very popular use case with our customers. So as we spoke earlier, we've got services like Direct Connect, which allows you to really ingest data at a high speed or at a very high volume into Amazon S3 or the storage. We also got import export services, which allows you to send the hard disk to us, or even we ship you a device called Snowball, which allows you to import multiple terabytes of data in single go. And once that has been imported and sits in the cloud securely, you can actually start running the EMR clusters or the Redshift-based data warehousing solutions on top of that to start analyzing that data and then share it back. Another important service is the Amazon Kinesis. We see a lot of customers now coming into real-time streaming domain, wherein they're asking for the dashboards to be updated and the statistics to be created in real time. So we have a service called Amazon Kinesis, which is a fully managed service for real-time data ingestion. And Kinesis has connectors to multiple other services, which allows you to do further analysis of the and processing of that streaming data that comes in. Enterprise applications, so Oracle, SAP, Microsoft, they're all our old-time partners and have certified their applications, middlewares, databases, etc., to run on AWS. And most of them also have something called license mobility. So if you've already purchased licenses, then for quite a few of their offerings, the license can actually be used as such into AWS. And in some cases, it's also available on a pay-as-you-go model in AWS as well. Most of these are supported to run on Amazon. Another very important aspect is the disaster recovery, DR sites, etc. We've got multiple different options by which customers can create a DR site, and that actually becomes the function of the cost they are ready to incur and the amount of RTO, RPO. So that basically becomes a trade-off of cost versus the time and the RTOs and RPOs that you would need for your businesses. So depending upon that, we've got multiple models like backup and restore, wherein you keep everything ready in Amazon, and in case of eventuality, you fire up the entire infrastructure, do a minimalistic or otherwise do a minimalistic setup in AWS, or have a complete standby of your physical site onto AWS so that in case there is an eventuality, you can fail over entirely to AWS. Multiple options there for customers to pick and choose there. So how are companies getting started with AWS? So this again would be important from a strategy perspective. So first strategy is dev and test. A lot of customers actually start with only dev and test environments, and once they get comfortable with the AWS platform, they've built enough skill set internally, or they got a partner roped in, that is when they scale to the more critical production workloads. Some of the examples are mentioned here. So Lionsgate and Galata Chemical, they're running their SAP dev and test environments on us. Tokyo Stock Exchange running Oracle Enterprise applications on us. So as you can see, the benefits include not only the cost reductions, but also the amount of time they or their teams actually spend in setting up the environments and making them production. Other strategy is to build new apps in the cloud. Those workloads are also shifting to the cloud now. The advantage here is that there is no legacy from which this application has to be migrated. They are cheaper and less expensive in the cloud. Much easier to build and faster to deploy, and you can also start leveraging the overall fault-tolerant infrastructure that's available in the cloud by default. You can see here that PBS, which runs video streaming service on AWS, and Qantas Airlines, which have built the entire hotel booking applications onto AWS from scratch. So those are faster to build, easier to manage, and from day one, you can start leveraging the best practices and the advantages of the cloud. Moving next to the other strategies, so strategy 3 and 4 are kind of linked to each other, wherein it's not an all or nothing kind of a scenario. If you have an existing suite of applications running on premises and you want to do some data transfer or you want to do some compute intensive workloads such as the analytics, etc., the customers, what they do is they transfer the entire data to S3, do the analytics in AWS, and then transfer the data back. Or they also do a lot of backup and archival, etc., onto AWS cloud. So that way, as I said earlier, it's not an all or nothing kind of proposition. You can always work seamlessly with what you have on premises and integrate that with AWS, and they can work in parallel. For example, Nasdaq and Nokia both are doing big data analytics, and achieve the cost reductions obviously, but it's the overall agility that they have been able to bring into their systems. Similarly, Macro Hill, they have been backing up their entire Oracle using Oracle RPAN into S3 without worrying about the storage capacity planning and all that. And this is the other way around, wherein the primary workload happens in AWS, or the critical applications run in AWS, but there is a certain part of the application that gets delivered from the on-premises system. So both these methodologies are possible. So for example, Samsung has the Smart Hub app on cloud, but whenever the financial transaction has to happen, the entire system switches onto the on-premises systems, and then it goes back to the AWS. The other strategy, or the fifth strategy, is migration, and this requires a little more wherein you need to really plan out and see which applications are totally independent of each other and have no dependency whatsoever from the other components. and first take those, and then over a period start migrating the other applications as well, plan for a cutover and migrate everything to AWS. Unilever, for example, has 1,000 websites with their 500 or so have been migrated, and they are migrating the other set of services and creating new ones in 2 days instead of multiple weeks. So that's the kind of advantage that they get. Similarly, Bristol Myers Squibb, they migrated their entire clinical trial simulation to AWS, which earlier was taking 60 hours and more. It now gets completed in 72 minutes. So more than the cost, it's about the entire speed at which you are able to execute the entire thought process. Netflix, I'm sure you would have heard about Netflix, and they are capable of consuming almost quarter of the North American bandwidth. And a few years back, they decided to move all of their apps into cloud and become cloud native. And we are seeing more and more companies go in this direction. All right, so I'll quickly summarize. So these are the aspects that sets AWS apart. The experience, as I said earlier, of having run the massive data centers of Amazon.com, the experience that we gained from there has been the part of the overall operations and the operations efficiency that we bring in, as well as the experience therein. The service breadth and depth, we've got multiple different services touching almost 60 now across the various aspects of IT. And we believe that those are important for any customer who is evaluating the cloud services, for them to see the entire portfolio, because as the services become complex, those things are needed. And if those are available on a pay-as-you-go model without any commitments and all, then that's always a preferred choice. Pace of innovation, the feedback is important to us. We have a history of rapid iteration and being able to deliver what customers demand at a very high pace. Global footprint, we've got multiple regions and availability zones across the world for customers to leverage without worrying about, they just need to capture the market, and we've got the infrastructure to support that business growth. Pricing philosophy, as we said earlier, we've done 50 proactive price reductions to date, and we continuously keep on innovating internally and improve our cost structures to pass those benefits back to our customers. And last but not the least, the entire ecosystem of system integrators and the software vendors that we have, along with the product, the marketplace products that we have, it gives us a very strong ecosystem of the SIs and the other product companies, so that customers are able to pick and choose the products they want and quickly launch them. Before we go into Q&A, some important aspects. Next steps could be you can sign up for an AWS account on aws.amazon.com. Take advantage of the free tier, very recommended. There are certain services in compute, storage, networking, database, etc., which are available for free for you to evaluate and start experimenting and get comfortable with AWS. In addition to that, we also have a number of labs and training courses that are available. And some of those are self-paced labs, so that you can do whenever at your own pace and luxury. Gain confidence with whatever steps are documented there, so that you get more and more accustomed to the AWS nomenclatures, etc. In addition to that, we also have the instructor-led classes ranging from 3 days, 2 days, and covering the topics right from basic architecture to the big data and other training courses. We've got multiple training courses. This is conducted by the Amazon instructors. Then we also have the AWS certification, wherein you can validate your technical expertise with AWS, and this is a well-respected industry accreditation today, so and also establishes your credentials. Thanks for attending the webinar. We kindly complete the survey that will be shown to you. That will be very important for us to judge how we did in the webinar today, and your genuine feedback will really help us in fine-tune for the future sessions. Thank you, and now we will jump into the Q&A. Please